Susie is climbing a flight of stairs. She is at the bottom of the stairs and she can either take 1 or 2 steps at a time. How many ways are there for her to climb 10 steps? When you see problems like this, you usually try to figure out how many ways there are to climb 10 steps. And a good method to approach this problem is if you try out smaller cases. Just to understand this problem is asking, you have a flight of stairs. She's at the bottom of the stairs. And she can either take 1 step or 2 steps at a time. So consider when there's only 1 step. Well, there's obviously, you can only take 1 step. Let's let F1 be the number of ways she can climb 1 stair, which is 1. Consider when she has to walk up 2 stairs. You can either go 1, 1, or you can take 2 steps at a time. So F2 will equal 2. Now for 3 steps, you can either go F3. You can go 1, 1, 1, 2, 1, or 1, 2. You can't go 3, so you get 3 ways in total. So let's write that. Now for 4 steps, you have 1, 1, 1, 1. You can go 1, 1, 2, 1, 2, 1, or 2, 1, 1. You can also go 2 steps at a time for both times. So in total, there's 5 ways. So we know that F4 equals 5. And F denotes, so if you have Fn, it's the number of ways you can climb n stairs. So we have this so far. Just to rewrite this so it looks better, we have F1 equals 1, F2 equals 2, F3 equals 3, and F4 equals 5. Now that you tried out some examples, it's a good idea to try to figure out the relationship between each case. So when I first saw this, I noticed that 1 plus 2 equals 3, 2 plus 3 equals 5. So I was thinking maybe there's a relationship between that. So if you think of Fn, I would guess that it's Fn minus 1 plus Fn minus 2. So if you're trying to find F4, it would be F3, which is n minus 1, and F2, which is n minus 2. So now that we have a general idea how it might work, we're not sure if this is true or not, but we're going to try to prove this. So to do that, think of a flight of n stairs. And if you're trying to find out Fn, the first case is when, in the beginning, Susie takes 1 step. And the second case would be when she takes 2 steps, just in the beginning. So consider when she takes 1 step first. When she takes 1 step, let's just draw this. She's right here. So now she took 1 step. Now, how many ways she can take this many flight of stairs, which is n minus 1, is just Fn minus 1. So we can conclude that if you take 1 step, it's the same as taking Fn minus 1 steps. There are that many number of ways. And the second case is when she takes 2 steps in the beginning. So now she's right here. And now there are n minus 2 steps left. So it's the same as Fn minus 2. And that's all because in the beginning you can only take 1 or 2 steps at a time, not 3 or 4 or 5. So we can conclude that Fn equals, when you take 1 step, which is Fn minus 1 ways, plus when you take 2 steps, which is Fn minus 2. So looking at this, we can see that it's the same as our original hypothesis. And since we proved this, we can conclude that the relationship between Fn, or the formula for Fn, is this. And now we try to use that to find this, how many ways we can climb 10 steps. So we know F1 equals 1, F2 equals 2. Similarly, now we know this, we can see that 1 plus 2 is 3. F4 is 2 plus 3 is 5. So let's just draw a chart. We know that, let's start with 3. 3, this is n, this is Fn. We know that 3 is 3. 4 is 5, based on this right here. So we need to go up all the way up till 10. So we can try to find that. So 5 would be 3 plus 5, which is 8. 6 would be 5 plus 8, which is 13. 7 is 8 plus 13, 21. And you keep going up like that. 54, 55, and 89. So we find that when the number of ways Susie needs to take to climb 10 stairs is 89. So that's pretty much how you solve this problem. If you want to check if you really got the concept of how to solve this problem, you can try using when Susie can take 1 or 2 or 3 steps at a time, and how many ways she can climb, maybe 15 steps in total. So that's how you solve this problem.